Hello class, this is a video tutorial on further composite functions. By understanding the composition of functions f of g of x as the result of g is substituted into f of x, we can learn more of the features of the composition. So I'm going to go straight into 3 examples. So here are the first 2. And here are the last 2 really, but it's just one example to really emphasize understanding the composition of functions. So here we go. Given these 2 functions, how many vertical asymptotes does f of g of x have? We could just do this the seemingly straightforward way by just making the composition. So f of g of x. So here's 1 on x, that's f. But wherever x is, we're substituting g. So x squared minus 1. Since this is a hyperbola, we can just say that the denominator cannot equal 0. And from here we can factor x plus 1, x minus 1 cannot equal 0. And from here we can see that x cannot equal negative 1 and x cannot equal positive 1. And from what we know with hyperbola, these also match as the vertical asymptotes. Okay, so there would be 2 vertical asymptotes. Now that is the seemingly straightforward version, which is perfectly fine for this particular example, but I'm going to go about it in a seemingly longer way to really get our understanding for future harder problems. So here we go. So f of x has asymptotes, has vertical asymptotes when x equals 0. So when this equals 0, we get vertical asymptotes. G of x, since g of x is going to substitute into x, g of x equals 0 when x equals plus minus 1. So we can find that by saying x squared minus 1 equals 0, x plus 1, x minus 1, and so we get x equals 1, x equals minus 1. So therefore, when x equals 1, g of 1 equals 0, and then, so follow that along. So when x equals 0, we substitute this first into g. G of 1 equals 0, and f of 0 equals a vertical asymptote. Notice here how we're going right from the beginning, x first, into g, and then the result of g goes into f. And that's when we can count the first vertical asymptote. Likewise, when x equals minus 1, g of minus 1 equals 0, and f of 0 equals a vertical asymptote. From here we can see therefore there are 2 vertical asymptotes. Notice how both get us the same solution, but this one relies on the algebraic method, which works for this particular example. But notice how with this, I'm going through, I'm starting at the end, then I work backwards in working with the condition that I'm using. So I'll repeat this one. F of x, since we're looking at vertical asymptotes, the vertical asymptote in f occurs when x equals 0. But 0 is the result I'm looking for in g, because the result of this will go into x. So when does this equal 0? I found it here. And then I go through the logic to show that when x equals 1, we're substituting 1 into g. We get 0 out of g of 1. And that goes into f, which gives us the first vertical asymptote. And we repeat that for the second x value of -1. Now let's compare this to the next example. You can pause at any time and give this a go yourself. So we have f of x has 3 roots, meaning it has 3 x intercepts, and g of x equals x squared. How many turning points does g of f of x have? Now notice with this one, we don't know anything about the function of f of x in terms of its equation, but we do know it has 3 roots. So how many turning points does g of f of x have? Well, first, let's work backwards. G of x, so we can say that g of x has a turning point at x equals 0. We know this just from this function. It's just a parabola. So at x equals 0, it has a turning point. Well, how many times does f equal 0? F of x equals 0. How many times does this occur? Well, as you can see, it says it has 3 roots. These 3 roots are, well, this root, f of x equals 0, has occurs 3 times. We don't know when it happens because there are no indications as to what the x value is for this. Well, since f of x has 3 roots, and I'll just make a possibility of what f could look like. F of x could have 3 roots, so 1, 2, 3. There's 1, there's 2, there's 3. This is a possible graph of f of x. And let's just say that these roots are a0, b0, and c0. So now from this we can see that when when x equals a, f of a equals 0. See, when a equals 1, sorry, when x equals a, f of a is a x-intercept. And from this we can see that g of f of a is also 0, because we're substituting 0 into here, and g of 0 is the first turning point. We can repeat this 2 more times. So when x equals b, f of b equals 0. And so from this we can see that g of f of b will also equal 0. There's your second turning point, and this repeats the third time. So in conclusion from all of this, I hope you can see that we're first using the features of f, and then the features of f substitute into g to understand g of f of x. So when x equals c, f of c will equal 0, and g of f of c will also equal 0. So there are 3, so therefore there are 3 turning points. So I hope that gave you an insight into further composition of functions. I will see you in the next video when we look through this last example here. Hope to see you then. Best of luck.